Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 21st, 2025, which means it came out just yesterday. The Big Hook is a system that generates several coherent three-dimensional assets from one image plus object masks in a single feed-forward pass, no optimization or asset retrieval required. The paper is titled SceneGen, Single Image 3D Scene Generation in One Feed-Forward Pass. And as we will see later, the implications for practical 3D content creation are quite significant. Beyond single images, the method even strengthens results when you provide multiple views at inference, and evaluation shows strong accuracy and speed. Also, the authors shared a GitHub repo. You will find the official PyTorch implementation scaffold, an MIT license, and a README with setup via Conda, high-level requirements, and a roadmap. Inference, training, dataset, and evaluation sections are placeholders for now, with checkpoints and code slated to be released gradually. Alright, this overview figure shows the pipeline at a glance. Small input photos at the top represent single scene images plus masks, while the large grid below displays the generated three-dimensional assets arranged coherently. You can see consistent furniture geometry and textures, which indicates joint asset synthesis and spatial reasoning in one feed-forward pass. The regular floor grid highlights relative positions, so chairs, tables, and beds land without collisions and with plausible scales. Building on that, this figure contrasts three prior strategies with the proposed pipeline, so you can see why a single feed-forward pass matters. The left column depicts two-stage systems that retrieve or generate each object and then fix layouts with extra post-processing. The middle column shows single image generators that place blurry assets with awkward geometry. The right column presents the unified path, where learned global attention and a position head produce textured assets and their relative poses together. Next, this figure lays out the full architecture, from inputs to outputs, so you can see how everything connects in one feed-forward pass. On the left, the scene image and masks feed the visual encoder, while the geometric encoder extracts global structure that guides relations. Across the middle, local attention sharpens per object details, and global attention fuses inter-asset context with position tokens. On the right, the position head predicts relative poses, and the structure and texture decoders produce the finished assets. Okay, this table compares methods across geometry, visuals, and speed, and the headline is that SceneGen leads almost everywhere. On geometric metrics, lower chamfer distance and higher F-score and intersection over union show much tighter shapes and layouts, which reflects better multi-object coherence. For visuals, higher clip similarity and DINOv2 similarity, plus lower FID and LPIPS, indicate crisper textures. Finally, the inference time column shows SceneGen is not the fastest, but it balances quality and speed well for multi-asset scenes. Moving from those results, two takeaways stand out. A single feed-forward pass can yield coherent multi-object geometry and textures with strong metrics, and the local plus global attention with a position head scales to multi-view inputs for even better shapes. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.